when we're dealing with expectation in probability, sometimes we can come across this type of a problem. I call it working backwards. So it might come in this form. So for instance, let's say I have 20 tickets in a raffle and my chances of winning is 0.25. And the question might say, well, how many tickets are there in the raffle in total? Well, we know that the total number has got to be, it's got to equal 1, hasn't it? So, you know, if you pick one of those tickets, you're certain of winning. If you had all the tickets, you would win a prize. So what we've got to think about is, how do we actually get 0.25 to equal 1? We know that 20 tickets equals 0.25. So what do I need to do to that? I need to multiply that by 4. So 4 lots of 0.25 will get me to 1. Now this is really called scaling. I do exactly the same to both sides. So therefore, if I multiply that by 4, it will tell me that the total number of tickets is 80. So if I bought 80 tickets, I would be guaranteed a prize. I've only got 20 tickets. What's 20 as a fraction of 80? It's a quarter, which is exactly where we started. I've only got a quarter of the tickets, so therefore my chances of winning will be 0.25. Let's just have a look at another simple example. Sometimes it's presented to us in a fractional form. So for instance, I might say I've got 7 tickets in a draw and my probability of winning a prize is 1/10. Okay, so again, how many tickets are there in the draw? Well, this time, what do I have to do to get from 1/10 to 1? I multiply it by 10. 10 times 1 is 1 and 10 over 10 is 1. So therefore, by scaling it, I have to do exactly the same here with the tickets, which tells me, so if I bought all 70 tickets, of course I'd win a prize. I've only got 1/10 of them, so therefore, that's right, I've only got 7 tickets. Okay, and that's expectation working backwards.